Like many people in our industry, I came into engineering because I wanted to change things. I wanted to make the world better by the result of my efforts. Ultimately, that change can only really happen with an appreciation of the wider dimensions of engineering, the ability for engineering to improve people's lives at large and small scale. In that sense, engineering has always been inextricably linked to politics. The relationship isn't always the same. Sometimes engineering invention has unintended political impact. Probably more often, engineering is delivering the current political will or agenda. A good example of the former, unforeseen consequences, is the wheel. Whilst there's a lot of debate about where the wheel was first discovered and engineered, be it Mesoamerica, Persia or the Eurasian steppes, its political and social importance are undeniable and can probably fill a whole talk on their own. But I'll give you 3 quick consequences. First and foremost, the wheel enabled much more efficient agricultural production by being able to transport people to and crops from fields much further away from the village, from the place where people lived. This led to a move away from communal farming, where everyone pitched in for a fair share of the yield, to single-family run farms, primitive systems of employment, and of course the need for bartering, because now you actually had to figure out how to buy and sell food, not just eat it. Secondly, the wheel had an impact on warfare. The reach of any army was no longer limited by how much food it could carry on its back, so armies who had been limited to fighting 2 or 3 days away from their home could now, by a combination of horses and wheels, wage war over much longer distances. And at least initially, the wheel gave the discoverer, if you like, the side with the best engineers, an advantage in battle of being far more agile. Ultimately, this had a huge impact on empire, which saw the Romans, for example, expand and control their empire by building roads solely to capitalise on the benefits of wheeled transport. Finally, and perhaps most importantly, in the yin, if you like, to warfare's yang, the wheel led to dialogue and transformed areas like the Eurasian steppes from being a series of disconnected cultures to a single interacting system. It allowed distant neighbours to come together, to share language, and of course to embark on trade. In a sense, if you like, the wheel was the internet of its day. As an aside, the wheel, or rather the failure to capitalise on it, was one of the major contributors to the downfall of the Mayans in Central America. They had discovered the wheel, actually in their rather sophisticated toy-making industry, but lacking domestic animals like the horse, they didn't make the leap to employing it in agriculture or in binding together their empire. So instead they were limited to localised and rather fruitless warfare, and more importantly, chronic over-farming, which may in part have contributed to their eventual collapse. To this day, the Mayan world remains rich territory for engineering's political impact. One of my favourite, much smaller scale stories is that of the retired Texan engineer Don O'Neill. In the late 80s, Don was involved in charitable work in southern Mexico and Guatemala. He and his group were shocked to find the number of children suffering from domestic burns. They found that the root cause was the centuries-old practice of cooking and heating houses with an open 3-stone fire with no chimney. It makes for a very quaint, rather smoky black and white picture, but it's actually incredibly dangerous. Smoke is breathed in by the entire family, with the most impact on women and children who spend the most time around the stove, and the entire inside of the house and its contents gradually get coated in soot. As well as the risk of burns, respiratory disease is chronic. 50% of the world's population still cook and heat their homes with wood-burning stoves, and the World Health Organization records 1.6 million people dying from the resulting respiratory disease every year. To put that in some perspective, it's a bit like Birmingham dying every year. Actually, it's a bit like Birmingham dying almost twice a year. Don, being an engineer, wanted to engineer his way out of the problem, and over a short period of time he developed, tested and began to install a simple cast concrete stove and chimney. The stoves come complete with induction workshops for the community and individual training for the families. The results were startling. Reported respiratory disease dropped by 60%, and the incidence of burns almost disappeared entirely. By design, the stoves are far more efficient, which reduces the consumption of wood by about 70%. Now, as well as reducing deforestation, this had a significant social impact for indigenous families, because the once time-consuming activity of gathering wood, was drastically reduced, so much so that the women in these families regained 2 days per week of their lives. This allowed them to use this time for commerce to improve the lives of their family, and on community organising, allowing them to become more involved in the local politics of the areas where they live. The politics of health has always been a key to engineering need, no more so than in Britain in the 19th century. Britain suffered 3 outbreaks of cholera in the 19th century, and over 250,000 people died as a result of the disease spreading so rapidly. Whilst London had sewers, they were only for stormwater. But the sanitary problems, and I'll spare you the details, were so bad that the government had no choice but to open them up to sewage, and ultimately this meant that the River Thames became London's largest open sewer. Whilst there was agreement on the problem, there was a lot of misinformation about the spread of cholera. The most popular explanation among politicians was the so-called miasma theory. This held that cholera was actually spread by smell. That is, if you could smell the bad air, you would catch cholera. And the story of cholera's eradication, and if you like, the end of the disinformation of miasma, was the story of 2 people, John Snow, a GP, and Joseph Bazalgette, an engineer. Ironically, while Snow's surgery was on Frith Street and Bazalgette's office was on Greek Street, both within yards of each other in Soho, they never actually met. Snow's contribution was in his research into contamination of the drinking water supply. Famously, he studied the outbreak of cholera in the area around Golden Square in Soho, and through meticulous interviews he mapped the incidence of cholera and isolated the cause to the Broad Street water pump. The pump had clearly been contaminated by a nearby cesspool under a house, and keep in mind almost every house had a cesspool in its basement at the time. His research was actually very clear, but he had very little luck with the politicians of the day, who found the likely cause and his explanation rather too unpalatable. So he ended up approaching the local parish council. Despite the seeming anomaly of the local monastery being unaffected, they actually mainly drank the beer they brewed, which they brewed with water from a different pump. The parish council nevertheless agreed, and Snow personally removed the handle from the Broad Street pump. The cholera cleared up almost immediately. Meanwhile, Joseph Bazalgette was working as a civil servant, becoming the chief engineer of the Metropolitan Board of Works. For years he made detailed proposals to the government of the day to construct a new and far more robust system of sewers. Every time he was turned down based on the miasma theory, or guess what, it cost too much. The turning point actually came in 1858 when London experienced one of its worst heat waves, and quite simply the stench of the river was too strong for the MPs, and they began to refuse to turn up to Parliament for fear of suffocation or, of course, contracting cholera through smell. Such was the level of desperation that within a matter of 3 days in July of that year, the bill to build London's sewer system was passed through a much depleted Parliament. Construction, with all its ups and downs, took 12 years, and Bazalgette's sewers were completed in 1870. Bazalgette's idea, like Don with his stoves, was a very simple one. All the current sewers ran to the river, so he constructed a series of super sewers to intercept them before they got there. This led to some of the most ambitious elements, being the low sewers to the north and south of the river, which required land to be reclaimed from the river, and ultimately the formation of the Victoria Embankment to the north and the Albert Embankment to the south. The result was a system that has undoubtedly saved hundreds of thousands of lives in London, and I think countless millions in its influence globally. So the political impact of the sewers is clear. What's equally clear is the slow response of the political system. Bazalgette knew what was needed, but politicians needed a disaster to force them into action. So small and large, engineering has had huge impact, and been hugely impacted by politics and by social change. If engineering has such influence and possibility, what are the issues of today which we should be working towards? Poverty, global warming, clean water supply for everyone. I think one of our biggest emerging issues is the same issue which ultimately Snow and Bazalgette were grappling with: upgrading our cities to cope with an increasing urban population. At the time of cholera in London, its population had expanded from around 1 million at the turn of the 19th century to almost 1.9 million by 1870. The engineering of London's sewers allowed that expansion to continue whilst maintaining and even improving the quality of life. London's population today sits at just over 8 million, But the Office of National Statistics predicts that it will increase by almost 1 million to top 9 million by 2020. And London is not alone. Worldwide, we have just passed the halfway point. 50% of the human race now lives in cities. By 2030, the UN predicts this number will reach 70%, and by 2050, if it's even possible to predict that far, they reckon it will exceed 80%. So a virtual doubling of our cities in under half a century. This has the tantalising mix of danger and excitement. Cities are the dominant driver of economic prosperity and quality of life for everyone, and most of us will be living in them. So what should we do? There is a strong systems perspective here. Cities are a set of, if you like, codependent systems. Natural systems, utilities, transport, and of course government, to name just a few. And the dialogue in these areas is developing, albeit with a high degree of debate and a huge degree of difference by geography. But cities at the end of the day are made up of buildings with people in them. And the dialogue at this level is not developed to the same degree. After all, buildings are where we spend 80% of our lives. So in human terms, they are one of the most important parts of our urban systems. I'd like to outline a few ways our buildings can play their part. Our buildings will need to respond to change, and some of the change will be good. Amongst other things, we are going to see our streets change for the better. The uptake of electric vehicles is accelerating at a rate of over 35% a year. And over time, this will change our streets. They will be quieter and they will be cleaner. We will enjoy walking and cycling in them much more. And of course, we'll want to open our windows of our buildings far more frequently. And keep in mind that this change has already started. At the current rate, this change will happen within the lifespan of the buildings we are designing today. So we should be acting now by delivering buildings with the capacity for natural ventilation, even if our streets are too noisy and dirty to support it. By doing this, we preserve the ability of buildings to consume as little energy as possible in the future as well as today. On a tougher note, our cities need to brace themselves for climate change. Most climate scientists will now tell you that climate change is no longer preventable, and that as well as redoubling our efforts to reduce further carbon emissions, we need now to be getting ready for climate change, for extreme weather events. Recent floods in the UK have reminded us of this. And of course, the staggering force of Superstorm Sandy in New York last year make this a very real and highly politicised issue. This is a shot of New York's financial district, the heart of the American economy, the largest economy in the world. Sandy's statistics are worth thinking about. So President Obama has just applied to Congress for $60 billion to repair the damage. And New York City was paralysed for almost 6 days, costing the American economy in the order of $25 billion worth of GDP. Our own office in New York, despite having a resilience plan to minimise this kind of disruption, was closed for 2 weeks. So imagine what would happen to your business if it was closed unavoidably for 2 weeks. This makes it beyond inconvenience. Climate change is a business risk and one which our buildings need to address. And I would suggest that for America, with Superstorm Sandy coming on the back of Hurricane Katrina in 2005, the decisive political moment has actually arrived, and we will see almost every city at risk in the US investing heavily in survival. It's a bit like the big stink in London. There is no other political option now but to invest in the engineering of cities. Unless, of course, we fancy the Mayans' path and ignore the warnings. So-called resilience has many more dimensions. One which is particularly important for the UK is power demand. Ofgem estimates that in the next 2 years, our national demand for power will be within 4% of the available supply, i.e. within the margin for error. This means power shortage in the UK is close by. And these figures might be conservative because they don't actually account for the likely shift to electric heat pumps or to the move towards electric vehicles. Again, turning to the US, you might remember the blackouts of 2004 when, due to a series of similar resilience failures, the east coast of America was plunged into darkness, and on one of the warmest days of the year, compounding an energy crisis with huge losses of data and connectivity for business. There are a number of ways to address this, which are all very building related. The first is an obvious statement: reduce the peak power demand of our buildings. It's interesting that in the political clamour for lower carbon footprints, we've forgotten this. And it's much more fundamental because managing peak power demand is far quicker and far cheaper than building new power stations. It also has an impact on the capital cost of buildings because connecting to the grid and all the kit that goes with it is actually a very expensive activity. And it's easier to quantify because it's an absolute. So using many of the techniques we already know and love, super efficient facades, natural light, thermal storage, and of course natural ventilation, it's interesting to turn the equation back into peak demand. And oh, by the way, if you reduce peak demand, you always bring down the carbon footprint. They go together. You just don't have to spend quite so much time talking about the far woollier numbers of carbon emission and all of the activity that goes with it. One of the responses to power resilience is to enable our buildings and even their components to manage their own power demand in response to the availability of supply. LG have just launched a new fridge for your house which does just this. It tracks two things. First, the availability of power in the grid via a signal the utility company will send down their wires, so that during peak times the fridge will allow its temperature to drift up. It'll do this for limited periods of time, knowing exactly how long a pint of milk can tolerate warmth before it goes off. Secondly, the fridge works out what your daily routine is by sensing how often you open the door. By doing this, it knows, for example, that you are not at home between 9 a.m. and 6 p.m, so it turns itself off, again allowing the temperature inside to drift up a bit without risking the food inside. Our buildings, on a larger scale, can do very similar things. This is the Crystal in Docklands, which is designed to manage its power demand in a similarly responsive and granular way. Again, sensing the available power in the grid, it will be able to prioritise where the power is used, selectively dimming lights, allowing temperatures to drift a little, and in some cases just turning things off. You'll note that I'm avoiding using the word smart here because I think it's a horribly confusing term, but if you hear the phrase smart grid or smart building, this is probably what it means. Returning to the availability of power, there are two more issues related directly to peak demand and carbon footprint. The first is performance. British cycling is famous for its attitude to performance. From that initial moment when Chris Boardman won an individual pursuit gold in the 1992 Olympics, British cycling has had a focused, incremental approach on every single aspect of performance. So from the fitness of the athletes, the weight-to-power ratio of the bikes, the specific configuration of frames for different people and events, even specialised training for each phase of a race, and of course the roundness of the wheels. It's been one seamless activity with a large and wide-ranging team, and I think we could learn a lot from British cycling's application to our own buildings. For years now, the process of making buildings has been a disjointed one. Buildings have been designed with the potential to perform really well, or at least to have a really good story around how they perform. They've been built without making sure they will perform, and then they've been handed over with almost no follow-up. So the result is buildings never reaching their potential, and peak power and annual energy use being hugely over their targets. This is no longer acceptable, and the government is about to start telling us it isn't in the next few years. So the emergence of minimum energy performance standards being just the start of that process. So we need to start looking very hard together at how our buildings perform. One of the first things British Cycling did was to collect data, any and all data they could find, about how well they were performing. And then they acted on the results and the conclusions. So I think we need to do something very similar. We need to actively share our lessons. This is a move that needs us to work together. So building operators, contractors, consultants, we need to share the lessons that we learn openly. And when the data points to a poor story, there needs to be no finger pointing, just a collegiate atmosphere of resolution. The other critical dimension to performance is how people feel. Are they happy and able to work hard? Are they able to support the business that they are working for to the best of their ability? Do they like the buildings they are in for the 80% of their lives? Again, here I think we need to be much more open about our data. We've started to collect and analyse data using some quite sophisticated tools, and they're very powerful and they give us very granular analysis of the data. But I do wonder if, a bit like the hotel world, we have room for a more public-faced feedback mechanism, something that allows people to lodge their opinions on their building. Think of the incentives it could provide and the impact it could have in connecting performance to the value of property. The hotel world has been transformed by TripAdvisor with very measurable improvement in quality, and I think there could be an opportunity for us in the broader building perspective. Finally, I'd like to make a link to perhaps the most political dimension of all, changing people's behaviour. There are many aspects to this, but I'm particularly interested in two. First, we live in this contradictory world where at home we have control over almost everything, and at work on the whole, we'll be lucky to find the light switch. And if we do find the light switch, it'll probably be rather complicated. This means that we fail to make a link between our own behaviour and peak power, because we can't. And at its worst, it means we then go home and fail there because the rest of our lives make us feel like we can't do anything. There's growing evidence that the thing that has the most impact over peak power is not actually the complexity of building systems or the sophistication of the building controls. It's of the behaviour of the individual people in the buildings. My colleague Mike Steitch, who is doing the next in this series of talks, is doing some great work in this field, developing a user interface for building that goes beyond the usual green screen in the lobby technology and actually allows people to interface directly with the building from their desk. The second aspect is tackling consumption beyond the building's own energy and water, looking more closely at the stuff that people consume while they live their lives in buildings. This piece of work here is something my colleague Adrian Campbell is developing, and I hope he'll be speaking in the series soon as well. The argument is that if you zoom out from the building to the development and the community, you quickly realise that the carbon footprint of the building is completely swamped by the consumption and the movement of stuff. So how do we plan buildings and their neighbourhoods to start to impact the 90% of our carbon footprint that is not related to the building itself, but is actually related to us and the way we live? That is to say, developments that positively encourage sharing resources, exchange and reuse programs, and that tackle transport as an integral issue to building design. So I tie these themes up as my fourth factor: influential buildings. Buildings that encourage us to think and act differently and reward us for doing so. As I say, perhaps the biggest political and social issue of the lot. So, to conclude, I think we're entering the age of the engineer. Perhaps I'd go as far as saying the age of the urban engineer, in every aspect. Our cities, these wonderful, vibrant places where people's lives thrive, are under huge threat. So as systems of urban government and infrastructure are stressed, we have an opportunity as building professionals and as engineers to contribute to the success of the buildings where we spend 80% of our lives, and in so doing, to contribute to the very survival of our cities. It's a political act, and we simply have to get it right.
It was fascinating. It was really interesting. I wasn't expecting it at all. In terms of the kind of the other side of engineering and thinking, and it's just really kind of heartening to know that actually all that good thinking is going on in the background, because. You'd hope that everyone in our industry is thinking like that, but you never quite see it because there's never really the time or the opportunity to have those kind of debates and discussions. But we should have more of them, I think.
I thought it was absolutely fascinating talk. I think it's excellent for the people for us to see your staff as real people, really making the impact of them as people, as well as the message that they're giving out to us. Really interesting story. Dave was brilliant projection of his, the take on it, and I think it just gives a different stance. It's not the usual, this is a building I've produced. It's making us think wider.
Absolutely fascinating. It's already provoked quite a bit of debate because I'm just off with Andy to have a discussion at Sadler's Wells about pretty well this very thing, and actually how we should consider issues like maximum demand. And so I'm almost straight away going to rush off and do something about ours. Excellent. I'm all revved up.
Really interesting, challenging topic for sure that we all need to think about. And I'm part of a project management team, so sort of have the opportunity to influence clients at an early stage of projects. In terms of determining briefs and things. So, a lot of food for thought, and it was sort of good for somebody to see their passion from the start of their career as well. So, it's great.